Now let's move on to t-test. Okay, so we have right now we have actually discussed an analysis like ANOVA analysis, then we have t-test 2, then finally we can now I will discuss some more another test which is t-test simple. No, it's different from t-test 2. So let me just change it to text here and t-test, and I'm going to put as a heading. So usually it's you mostly used for two types of thing. I will give you two examples. The first example is one sample text. So we have our, let me just put a code block here. So basically this is where you actually test the mean by some hypothetical mean. Like you assign some hypothetical mean. So let me show you mean, and sorry, we have to actually, yeah, you can't actually put a space in between your variable names. So we have a hypothetical mean is equal to 10, then we are going to perform simple t-test analysis, which actually conducts analysis and look at the okay the what is our actual mean and what is the difference between the hypothetical mean. So basically the number of notations you can actually put and define here. So I'm going to define here, you can see we will define like h comma p comma ci comma stats. So this is how you actually define t-test. Then we will pass the input argument. So in our case we will first define our data marketing data, then I will perform the analysis on first order profit, which is also a data column in our data set. Then I pass the second hypothetical, and then the second thing will be the hypothetical mean, and the first one for one sample t-test will be actually the column you actually conducting the analysis on. So right now I'm going to put hypo mean, that is. So let's just run it, and before we do that we can actually create some descriptive fprint statements to that will actually help us visualize it. Okay, so for example let's say fprint f, we say sample mean, then colon, then define percentage 2 dot percentage dot 2f, and then finally print to the next line. And within for that percentage 2f we will pass the input argument stats, and then using structure notation we will use t stats. Okay. And in the same way we can like also define the p-value, and for that purpose we can use the write the same station f print f, then we have our p-value, then we have dot colon percentage dot 4f dash n comma p. Okay, so that's how it is. So let me just first run it for you. Okay, so it's without s. So this is how we actually done our analysis, and we want to see actually based on thing like is there any difference between the hypothetical mean and the actual mean. So we can again use the same p-value notation here. Let me just copy that here and paste it down here, and we say that if p is less than 0.05 null hypothesis, there is a significant difference, and if greater than 0.0, then we say fail to reject null hypothesis, there is no significant difference. So let's move on to the next topic here. Okay, so we have done that. Now let's move on to the next analysis, like example 2 sample analysis. So let's do it. So we have example. We will now use the same function to conduct another analysis, which is known as 2 sample analysis. T-test. So basically its notation will be quite same, and we will use the same notation here. Let me just put a box here. So it will be like H comma P comma CI comma stats. Okay, then we pass the function name T-test, and then we will pass the input arguments that we want to actually see is there any significant difference between the means of two column values. For that column it could be anything like per continuous, for example marketing, and then we write first order profit, and the next one could be like total profit. Okay, and let's just run it. Yes. Okay, so we have h1, and if you recall that h1, it means that we reject null hypothesis, and if h is 0, it means that we accept null hypothesis. Okay, so let me write it down for you so you can remember that h is equal to 0, we accept null hypothesis. Okay. Oh, and if h is equal to 1, we reject cis. And what is does it means for p? So here it means that p should be less than 0.0.